What's going on YouTube? It's the Middle School Math Man. This video is going to be on adding, subtracting, and multiplying radicals. So, we talked about the class before how we simplify non-perfect square roots and cubed roots. So this is going to kind of take it to another step. So we're going to take those non-perfect square roots and cubed roots, and now we're going to look at like terms and how we can add, subtract, and multiply multiple radicals together. So, just a quick little warm-up. If you remember back to like terms, whenever we had something like 8x minus 3x, we noticed that they had the same variable, so that means they're like terms. We could have something like 4x squared minus 2x plus 8x squared. So my like terms there are 4x squared and 8x squared because they have the same exact variable, the same exact exponent. So that would be 12x squared minus 2x. So with that kind of thought, we are going to apply that to radicals. And again, radicals just means the square root or the cubed root sign. So in order for radicals to be like terms, they have to have the same exact sign. So in this first problem, we have two square root signs, and then it has to have the same number underneath the radical. So the square root of 11 here is kind of like the x in the 8x plus 3x. That means they're like terms. So the number underneath the radical is very important. It has to be the same in order for those to be like terms. So this first problem, all we're going to do is we're just going to add the numbers on the outside of the radical. It's just like this idea over here. That common variable or that common number stays the same, and then we just add the number in front. If we look at the second problem, now we have subtraction. 25 minus 7 is 18, so we have 18 cubed root 3. Now it's getting a little bit more difficult because before we add and subtract things, they need to be in the simplest form. So in this third problem, 5 square root 2, that's already in the simplest form. 7 is just a number, so that's in the simplest form. 18 is not, though. We can get 18 into its simplest radical form. So that's where we're going to do the factor trees, which we did last class. So 18 breaks down into 6 times 3, and then 6 breaks down into 3 times 2. So I'm going to rewrite this. The square root of 18 is 3 times 3 times 2. Then I have minus 5 root 2. Then I have plus 7. So we have a pair of 3's. So I'm going to take the square root of 9 and bring a 3 out front. So when I simplify this, I'm going to have 3 root 2 minus 5 root 2 plus 7. So now I have some things that I can combine. So that's very important. In order to add, subtract, you need to have them in the simplest radical form. So basically, you're looking for numbers that aren't prime underneath the square root or the cubed root. So 18, we broke that down, and then we're left with 3 square root 2 minus 5 square root 2 plus 7. So we can combine the square root 2, so we're going to get negative 2 square root 2, and then we can't combine plus 7 with those, so we're just going to leave it on the side. Now the last addition and subtraction problem, it looks really bad because there's 4 different terms, but if you think about it, all these 3's, all these square root 3's are already simplified. So the only thing we really need to simplify right away is that 27 there. I'm going to do it over here. 27 is not in simplest radical form. You can break 27 down into 9 times 3. Sorry, it's not letting me write down there. 9 times 3, and then 9 breaks down into 3 times 3. So what I'm going to do here is I'm just going to rewrite all of these terms. Now the 27 was 3 times 3 times 3. So I need to reduce that square root of 27, which I rewrote. So again, I'm going to rewrite everything. And I might run out of room, so I might need to do some erasing here. So I have a pair of 3s, so I'm going to bring the pair of 3s out front. And there's already a 5a out front. So out front, I'm going to have 5a times 3, which is 15a. So that is what I have currently. Now, like I said, I'm going to run out of room. So I'm actually going to erase this previous step. All right, so that is what I'm with now. So we talked about how the number underneath the radical has to be the same. But if you notice, we have on the outside, we have 13a squared, and then we have negative 4a squared. So we have a squared, and then we also have just an a. So another thing you have to look out for is not only do the numbers underneath the radical have to be the same, if you have variables on the outside, those also have to be the same. Just like what we talked about up here that I just underlined in yellow, the variables have to be the same. So I'm going to combine the a squareds together. So 13a squared root 3 minus 4a squared root 3 is 9a squared root 3. And then I have negative 2a root 3 plus 15a root 3, so that is 13a root 3. So that is the video on adding and subtracting radicals. So just a couple things to keep in mind just as a quick summary. In order for you to combine them, they have to have the same number underneath the radical. If they have variables on the outside, they also have to have the same variables. So that last problem we just did, the a squareds combined and the a's combined. And then you just have to make sure they are in simplest radical form before you add and subtract. So like the 18 here was not in simplest radical form. The square root 27 was not in simplest radical form. So that's where you do the factor tree.